Hangzhou Jinjiang Group and Zhejiang University have jointly developed differential density circulating fluidized bed refuse incineration and power generation technology with autonomous intellectual property rights. This technology is the 9th generation technology since the first generation was developed in 1998. This technology has been recognized as one of the main 5 technologies in the world. After a refuse transport truck enters the plant, it is first weighed on a truck scale, enters the unloading hall, and then dumps the refuse it has carried into the raw refuse pit via an unloading gate for storage. In the raw refuse pit, a refuse crane handles and stacks the refuse to allow the dripping of percolate. Stacked refuse is placed in a refuse crusher for crushing and magnetic selection and is then transferred to a finished product refuse pit via a conveying system. For plants with only one refuse pit, pre-treated refuse will be returned to the original pit. For refuse incineration, the crane will grab refuse and put it into the reception hopper of the refuse feeder of the incinerator. Refuse in the hopper is constantly conveyed to the incinerator material drop pipe by shaft-free screw feeders at the furnace front in a sealed and even manner, and falls into the incinerator by gravity for incineration. After incineration, the slag is cooled in the slag cooler to recover heat and then subject to iron removal on a conveyor belt. Later, the slag is conveyed to the slag bunker and transported outside for comprehensive utilisation. It can be used to make bricks and pave road surfaces, etc. Flue gas generation by the combustion of refuse inside the fluidized bed passes the dilute phase area at the upper part of the furnace to enter the high temperature separator, which separates high temperature particles in the flue gas exceeding D50 and returns them to the furnace to recover heat and increase fly ash burnout ratio and promote saving of auxiliary fuel and stable incineration. High-temperature flue gas after separation undergoes full heat exchange with heat surface in the tail flue duct to increase temperature and pressure of furnace water in the boilers. To convert this water to superheated steam, it is guided into the steam turbine via steam injection pipeline to generate power. In addition to providing power supply to the plant itself, all surplus generated power will be delivered to the grid under United Dispatch by the power system. Flue gas coming out of the tail part of the boiler will enter a semi-dry flue gas cleaning system. Before the circulating turbulent reaction tower inlet, active carbon is injected to control heavy metal and dioxin. Slaked lime is injected into this tower to control acidic gas. Also, high-pressure atomized water is injected into this tower for humidification and activation to promote the reaction. Bag deduster features dedusting efficiency not less than 99.9% and can filter dust in flue gas with high efficiency. Flue gas, after acid stripping and filtering and purifying by bag deduster, is drawn by induced draft fan into the stack for venting to the atmosphere. Fly ash collected by the flue gas cleaning system is conveyed by a pneumatic conveying system to the ash silo for storage. This fly ash will be subject to comprehensive stabilizing treatment according to its properties. Percolate, extracted from refuse during storage, is treated by a biological membrane process and reused after qualification. Hangzhou Jinjiang Group, the leader in waste-to-energy technologies.